And the things I'm going to be looking at are the first order forward difference, first order backward difference, and the second order difference. Okay, so I'm going to bring Excel in. Right. So what I'm going to do is I'm going to calculate. The first derivative of e to the x, and I'm going to do that at x equals 1. So I'll just put 1 in this cell B1 here, and I'm also going to define h. Actually, no, I'm not going to define h. What I'm going to do is actually I'm going to define a column of h values. Okay, so I'm going to start off at 0.5, and what I'm going to do is I'm going to halve my h values. So that when we get the finite difference calculations, we're going to see how the error decreases as h decreases. Okay, so the first finite difference approximation I'm going to use is the forward difference, which is given in equation 5.14 in the notes. Okay, and what this is, okay, so it's f of x plus h. Now I'm going to use e to the x, so exp for the exponential function, and b2. So I'm using cell B1, and notice I've used dollar signs here. Now this fixes this cell reference. Okay, so I'm going to be copying this formula down, and I want to be using cell B1 each time, so hence I've used dollar signs there. Okay, so full difference is that's going to be plus whatever my h is. That's minus f of x. So again, it's $b $1. And that's going to be divided by h. Okay, so this gives me an approximation of the first order full difference of e to the x. Now, if I just mouse over this little square in the bottom right hand side and drag down, you can see it just copies the formula down, and you can see as h decreases, my approximation is getting closer and closer to e, which is 2. So what is e? 2.718. Okay, so it's getting closer to that. Okay, I can do the same for the backward difference. Okay, so this time it's e to the x, so e to the $b$1 minus e to the x minus h. Okay, and that's all divided by h. And again, if I copy down, you can see it getting closer and closer to the actual value of e to the x. And I'm also going to do the same with the second order central difference. So that's e to the x plus h minus e to the x minus h. That's all divided by 2 times h. Okay, so that's first order forward, first order backward difference, and second order central difference. Okay, one thing I would like to do is actually calculate the error. So the exact value, as we said earlier, was 2.7182, so that's just e. So what I'm going to do is calculate the errors here. So what I could do is just, I'm going to use the same h there, so if I copy that down, that just copies h down. Okay, so the error for the forward difference is going to be equal to the absolute error of my exact value, which is in cell B9, so $b$9, because I'm going to be copying across, minus whatever that approximation is. Okay, so you can see the error was 0.8085. And I can copy this down, and as you can see, the error for the first order forward difference gets smaller. I can also copy this across, okay, because I've got a mixture of relative and absolute cell referencing. Okay, and you can see second order error gets quite small. So I'm just going to copy and paste in my column headings. Okay, well, as I mentioned in the lecture and in the notes, it's useful to have a log-log plot of this. So what I'm going to do is select all of my error values, and I'm going to insert an XY plot. So I'm going to use this one, which is an XY plot with straight lines. Okay, so what's happened here is actually used, I need to flip the data, so I'm just going to right click on this. If I select the data, and you can see here it says switch row and column, so I'm just going to click switch row and column. Okay, there you can see. So now we've got our plot. At the moment, this is not a log-log plot. Okay, so we have linear scale on both x and y axis. So to convert it, if I format it, right click on the axis and format it, I'm going to switch to logarithmic scale. And if I do the same for the vertical axis, so format that axis and switch to a logarithmic scale. Okay, you can see now we have them as straight lines. Okay, it's not quite as elegant as the MATLAB plot. If you've seen my video where I've done this in MATLAB, it's not quite as elegant, but you can still get the log-log plot. Okay. Right, one final thing I'm going to do is estimate the order, estimate order of approximation. And so what I'm going to do is copy column headings. Okay, so I'm estimating n. Okay, so the way we do this is I take the log of my worst error, which is the one with associated with the largest value of h, minus the log of the best error. Okay, and I divide that by the log of the largest h minus the log of the smallest h. Okay, and you can see for first order forward difference, n is approximately 0.107. Now theoretically it should have been 1, so that's quite close. If we copy that across, so backward is 0.86. One thing I haven't done here is because I copied it across, I'm using h, so I need to put a $ in front of the column letter A, and do that again. Okay, so you can see both first order forward and first order backward have n estimates of close to 1, and second order approximation has an n estimate close to 2.